My name is Victor Digomao here, and in our class once again, like I promised, we'll be bringing more problems that has to do with the circle, the sector, the arc, and the segments of a circle. If you look at this problem here is describing a door, an entrance to a house. Okay, and it gave us some descriptions about this door and asked us to calculate in the first question the perimeter of this door, and the perimeter of this door is to be presented like this: 5 plus 6 plus 2 root 2. And then the second question say find the area of the door in terms of root 2 and pi, taking sine 45 and cos 45 to be 1 over root 2. So how are we going to, handle this question now? I will take it like this. We know that perimeter is distance round an object. That's perimeter, distance round an object. So what we are talking here is this arc, this side, and this side. Okay, that's exactly what we are talking here. But if you are observant, you realize that this DE, because this is a rectangle, this DE is not given. And there's something that can give us that, because they say that there is an arch here, which is a quarter of a circle. So if you look at this now, you see a quarter of a circle. The angle there is 90 degrees, the radius is 2 cm, and this is obviously an arc of that circle. So if I make a dot here, I will be getting something, and that is chord AC, which is equivalent to DE. So I know how I can calculate that chord, and once I do that, it's equivalent to this DE. So I will not have any problem knowing the value of DE when it comes to adding DE. Okay, so let's take the first one. I'm thinking the first one I should take is possibly the length of that arc. Yeah, let me go in that first. Let me take that first. I will say length of arc A, B, C. Length of an arc is given by theta over 360 times 2 pi r. Here I have theta to be 90 over 360 times 2 times pi, because they say we should leave it in terms of pi. So I'm not going to replace pi with 22 over 7. Then times the r there is 2 times 2. That is r, sorry, not r squared, it's 1r. I thought I was calculating area now. So it will be 2 pi r, which is 2 pi times 2. Okay, so 90 will take away itself 1, take away 364. Yeah, you see that this 4 will cancel itself 1 and take away this 4. You can see 2 and 2 here. So what is left is 5. That's the length of the arc. Okay, so the length of that arc is pi. The length of that arc is pi. Okay, so you can see that. Now we can come back and also calculate the length of this chord AC. So I can say length of chord AC. Length of that chord, the formula we use to calculate the length of the chord when the angle at the center is given is 2r sine theta over 2. So we use it. Chord AC equals to 2r sine theta over 2. That's 2 times 2 for r, then sine 90 over 2 over 2. So this is 4 times sine 45, which they asked us to use 1 over root 2. I hope you know that 1 over root 2 is equivalent to root 2 over 2. So this is 4 times root 2 over 2. Giving us that shows that we shouldn't change it to decimal. That's the implication. We should treat it as sod. Okay. So I'm sure this cancels itself 1, cancels here 2. Finally, we have length of this arc AC to be 2 root 2. Okay. By implication, it then means that this place is 2 root 2. Okay? It's 2 root 2. Then, if that is the case, I think all the information we need to calculate the perimeter of that door is made available. So let's see whether you can arrive to something like this. Therefore, the perimeter is arc A, B, C plus this length CD, okay, then plus what again, DE plus what now, AE, okay, and then this one is pi plus 3 plus 2 root 2 plus 3. So this is pi plus this and this will give us 6 plus 2 root 2, which is what we have here in cm. So that's the length of the, not length, that's the perimeter of the door, the perimeter of the doorway. Okay, so what else did they ask us? They say we should calculate the area of that doorway, and if you look at it, you see two things there. You will see a rectangle here and a minor segment inclusive. Did you see that? Look at a rectangle. You can shift this one down and then this one stays separate. So I will calculate area of this rectangle and then calculate area of this minor segment and then add both of them. That will give me area of the doorway. Okay, so let me go to that. So I will start with, I will say area of the door is area of the rectangle, which is length times width, and that will give me 3 times 2 root 2, which will give me 6 root 2 in cm, okay, squared. I'll keep that. Then area of the minor segment is area of sector minus area of the triangle there, and this will give me theta over 360 times pi r squared, which is for the sector, the entire sector, the whole of this. We have done several of these in our previous classes, so please, you can check out on those classes. Then minus area of the triangle, which is half r squared sine theta. Okay, so this is 90 over 360 times pi times pi, because they say we should leave it in terms of pi. So I'm not going to replace this by 22 over 7. So this will be pi times 2 times 2 here minus 1 over 2 times 2 times 2 again, then sine 90. Okay, sine 90. And of course, you know, this is 1 over 4 times pi, then times 4 minus. Of course, this is sin 90 is 1. Yes, sin 90 degrees is 1, and then we have 4 here over 2, which will give us minus 2. And here, this 4 will cancel this 4 and give us 5. So that's what we obtained from area of the minor segment. So we can now summarize and say area of the doorway will now be area of the rectangle, area of the rectangle, area of rectangle plus area of minor segment. So this one gave us 6 root 2 cm squared plus this one that gave us pi minus 2 in cm squared. So both of them will give us 6 root 2 plus pi minus 2 all in cm squared. Okay. So if you look at it, you still see that it is expressed in terms of root 2 and pi. It's still expressed in terms of root 2 and pi as the question demanded. So there are 2 things we did here. We calculated perimeter of this doorway and we also calculated its area. We also calculated the area. So I am trusting God that this explanation I gave here is very, very clear. It's very, very clear. So please look at it again and again. And I implore you to please like our video and share it to someone out there. Help us to, help us to reach out to as many persons as possible out there, because this is a project. Our intention is to bridge the gap between the failure rate in mathematics, of course, to bring it to the understanding of everyone out there, to know that, of course, during our time when we were coming up, these are some of the issues we faced. Shortage of mathematics teachers in schools, and that's why we have looked at it as something that is worth taking, to be an ambassador of mathematics, to be someone that can propagate it and talk to everyone out there, and to deploy every possible strength we have within us to reach out to as many students out there as possible, to help them to understand mathematics and to pass their exams and to emerge with flying colors. Please share this video to them and then subscribe. Be our motivation in this project. And if you are out there, you think you can partner with us, we will be waiting. Our email is down there. We will be waiting to receive your message. Please, thank you so much for being there. God bless you.